Okay, welcome you to my YouTube channel. And today I'm going to be starting my AI slash machine learning project series. And I'm going to be doing it with something very practical and exciting. I'm going to be using machine learning to detect or predict anomaly within a data set. The data set we're going to be working on today is a sensor data, an engine data set that comprises columns of engine sensor readings. So with this, I'm going to be predicting anomalous character in each of these sensor. You know, the advantage or the application of this project is to predict this sensor reading in earlier, so we can be able to detect engine fault before it develops the fault. So that is why I am, you know, modeling and training this engine sensor data to see if I can detect an anomalous character or behavior in the data set. So by first doing, I'm going to reconnect my collab runtime, and as you can see, it's initializing over here. And let me walk you through my steps or things I'm going to do in this notebook. It's a quick project that I want to show in my YouTube video project series, and this happened to be the first video. So just stick around and watch how I was able to predict and print out a data set that contain only anomalous data. So firstly, I'm going to mount my drive, connect it to my Google Drive. That's where my data is. So yep, yep. Come on. Okay, mounting my drive now. Before we load the data set containing the engine sensor reading, and the data set has thousands of entries, collected from individual machine. This entry include value from multiple sensor monitoring engine codeouts. Yeah, monitoring engine codeouts. Why are you wasting time? So she got done. Sorry. Sorry about that. Maybe I should rerun that. Okay, now. Oh, good to go. Okay, our drive is mounted successful. It should be successfully, yeah, mounted successfully. So, the libraries that we're going to be using today, I'm going to be using the matplotlib, numpy, matplotlib, the seaborn library. Then, for processing data, I'm going to import the standard scaler. So, let me run that. Let me run that. And let us load our data where the readings and the columns and everything we're going to be training today is. So you can see the training data. I'm loading it from my drive, my Google Drive, content drive, my drive, collab, blah 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 blah, and all that. So let us visualize the first 5 row on our engine data set. Let's see what it takes. And one thing about this, also importing the test data set to predict on once I'm done modeling it. So let's check it. Let's check out our data set. In our data set, we have 26 column, and the first column is the unit number. Though we might not be needing this unit number for our training, because it's just like as if as it's an in is it index unit number. I don't know. Maybe it's an index because I did not check the data dictionary for this data set because I just downloaded it from Nope. I thought uh one of my instructor gave me this data. So gave me this data. So I didn't have access to the data dictionary. But notwithstanding, we are still going to train this data set. So time in cycle, open setting one, open setting two, open setting three, sensor. These are the sensor columns we're talking about that we're gonna be developing our isolation abnormalous data from, if there will be. So you can see, like I said before, we have how many columns? We have 26 columns. We're going to reduce this to 24 after removing our units number and time cycle, because I don't think we'll be needing that for the training. So, and also let's see our test data set. Let's see our test data set, because that one also is very important, because we're going to produce with the two data sets. So still the same thing. We have the sensor, we have the open setting and blah blah blah. So let's check the info. Let's see how many missing or not missing rows we have here. Actually, we don't have any missing number, any missing rows, and our data set is set as float, and majority is float and a little bit of int. We have the 1, 2, 3, 4, just for int. So we are good to go to model this data set, because without much data set preparation and the rest. So do we need to check the test info? Okay, let's just check the test info. Let's see. Boom. Good. So let's move ahead to the data processing. We have to process data and remove some column that will not be needed, and also standardize the feature values so we can commence the training. So feature column for code in training df. Yeah, I'm just trying to remove unit column, unit number and time in cycle from both data sets. I mean um the train data set and the test data set. So here it's this. That's why I did this, and standardize it. Let me run that, because we're gonna be needing that for. And here is the output. So isolation forest is a model used for training anomalous data. And here I instantiate my isolation forest to be ISO forest, and the okay random state, and the continuation to be 0.25, random state 42. I just want this result to be reproducible. That's why I just included the random states. And I have to fit my data. I fit in the S train scale data. Then I have to produce on both test data set and also train data set. So I'm going to run that now and see. Then produce on both sets. You can see now the green bar is our normal data, while the red bar is the anomaly data. So let's do our 2D visualization for this. Whoa, wow. This is, you can see the blue is the anomalous data, while the red is the data that are normal, the points that are normal. So you can see, let's predict and also select the anomalous data out of the main data set. So what I'm doing here is I'm trying to collect the anomalous data from the normal data. So let's print it out so that you see what I'm talking about. Okay, okay. To avoid, there's something I figured. Yeah, let me just do something like so that you see what I'm talking about. Our train anomalies. Oh, sorry. Train anomaly df dot head. Yes. These are the abnormalious data sets. So you can see the readings is minus 0.1, minus 0.0006, minus 0.0010, and the rest. Sensor reading, sensor reading one. Okay, so let's check the length of this data set. Let's check the length. Let's check the length. Length, length, df. I have 1032 rows for the train abnormal. Let's check for the, is it test? Yeah, test. Test. Test abnormal anomaly data. Add. Okay. Here it is. I want to check something because I've not really checked this out before, but after seeing this, there's something I like to check. Okay. Yeah. Sorry about that. Then let's check the length and see how many it comprises inside our test dataset. So I'll be doing learn test test anomalies. Still the same numbers of, I think this model might be right a little bit because it's detecting the same number in test and also in train dataset, but don't let us fall for it. Though we've seen the visualization that it has predicted a number of anomalous data, but don't let us fall for it. There's something I would like to do again. No, I want to compare. I want to check. I have 0. Let me check this data set from the beginning. Data set from the beginning. It has 0.000 readings. So what makes this model detect that this is an anomalous data and not a sensor? Well, with this my notebook, I was able to print out the data that I feel that are anomalous in nature and the ones that are normal. So in my data set, I was able to print 1032 abnormalous data. You know, feel free to tell me what you feel, and don't forget to comment, drop your takes on this my notebook, and don't forget to subscribe, like, and share this video because it's going to make me do more and also continue uploading my project series data. Project series data, no? Project series project. The project of the sorry, my project series of video. It's okay. For now, I'm going to say thank you for watching, and also don't forget to subscribe to the YouTube channel to make this project video more exciting for both of us. And the next video, maybe I'm going to be training a regression or a classification project problem. I'm going to be solving one of them next my next video, and I see how to prepare the notebook so I can present my video. But for now, I'll say have fun and have a good day or good night, whatsoever and when you are seeing this video. Thank you very much.